So this is for 2.8. We're going to go over example 2, where you need to find the x and y intercepts in any local max or min. Now you're going to do this by using your graphing calculator. So we're going to do part A together. So we have f of x equals x cubed minus 3x squared plus 6. I'm going to go ahead and plug this function into my graphing calculator. So we have x cubed, so I do x caret key cubed, and then we have minus 3x squared, and then we have plus 6. Now go ahead, I'm going to go back for my window where it is the standard, so from negative 10 to 10 and then negative 10 to 10. Now go ahead, press graph. There you go. Now the first thing we're going to do is find the x-intercept. That is where the graph crosses the x-axis. As you can tell, we only have one x-intercept. To get this, we go to second, trace, and you're going to go to number 2, which is our 0. You're going to press enter. Now to know your left and right bound, I'm going to go ahead and draw the graph here. Just kind of sketch, really. Okay. Now here what you want to do, so you know which one's the left and right bound, is draw the line, okay, that goes right through your x-intercept. Now anything that is to the left of this line, okay, so that means anything below the x-axis in this case, that's going to be your left bound. Anything above the x-axis will be your right bound. So go ahead, I'm going to move the cursor. So it just needs to be somewhere below the x-axis. Press enter. Remember, right bound means anything above the x-axis in this case. Press enter. Yes, make sure you press enter one more time. And here you can see your x and y values. Now I'm going to go ahead and round to the nearest tenth. So I'm going to use negative 1.2. Now when we write our x-intercepts, I'm going to write it as an ordered pair. So my x-intercept is going to be negative 1.2 and then 0. Okay, so now the next thing we have to find is our y-intercept. Remember, y-intercept is where the graph crosses the y-axis. Okay, so we have to figure out where it crosses the y-axis. To do this, we go to second, trace again. Now we go to number 1, which is value. So here you want to press enter. Now remember, to figure out our y-intercept, our x value should be 0. You press enter, and then they give you your answer here. Just like with the x-intercept, we're going to write ours as an ordered pair. Okay. Now the next thing is we're going to find a local max. So here we're going to write it as an ordered pair. Now notice right here, right where the hump, it goes up and then goes back down, that's going to be your local max. So I'm going to go second, trace, and because we're trying to find the max, I'm going to go to number 4. Now left bound just means the left-hand side of the hump, so anywhere on the left-hand side, and the right bound means anywhere on the right-hand side of the bump. Now don't go over here. We want to just be right near or close to our local max. Remember, press enter again for your guess. And then here, basically what we got for our y-intercept should also be our local max. Now, some of you might get this or a little bit different. Remember, anything e to the negative 6, if we move this decimal over to the left, this number should get closest to the value of 0. So we're going to round this x value to 0. So that means our maximum is at 0, 6, just like our y-intercept. So we have 0, 6. Okay, the last thing is we're going to find our minimum here. So that's right here. This is the minimum we got to find. To do this, we do second, trace, and you're going to go to number 3 for minimum. Now, left bound means we have to be close to our minimum, but it has to be on the left-hand side. Okay, so we can't have our cursor all the way over here. So I put it as close as possible as I can, but it's still on the left-hand side of my minimum. Press enter. Right, I need to go on this straight line somewhere. And remember, press enter one more time for your guess. So here x, now some of you might just got 2, some of you might got 1.9999. We're going to round to the whole number here. So our x value is 2, our y value is 2. So that means our local min is going to be at 2, 2. There you go. Okay, so that's how you find your x and y intercepts and any local max or min using the graphing calculator. Now make sure if you need to pause the video so you can always go back, okay? Or if you need to do it on your own graphing calculator, you can try it, watch what I have, and then try it on your own. So let's go ahead, let's talk about this one. This is your half sheet of paper, the yellow one that you got. Now this is using a graph. You can figure out the domain and range, and then figure out intervals of when the graph's increasing and when the graph is decreasing. So domain. Now remember, domain is our x values, range is our y. Now we look at our x values, remember that's the horizontal line. If you look, we can see that our x values, this graph is hitting all of the x values, all of the negatives and all of the positives. Now because we're writing our domain and range in interval notation, this would mean that we go from negative infinity to positive infinity. Now range, remember that is your y value, so the up and down. Now if you notice, our arrow is facing down, so that means this line would go on forever in the negative direction, and this arrow is going up. So that means our range would always go more positive as well. So that means we're actually going to hit all of the y values. So just like the domain, our range is going to be from negative infinity to positive infinity. Now the next one is we're going to talk about intervals for which the graph is increasing. That means if you're reading the graph left to right, in which the line is going up. Okay. Now when we write this in interval notation, we use the x values for this. Because basically what we want to know is between what x values is our graph increasing. Okay. So use x values for your interval notation. Now I'm going to show you here where it's going to be increasing, and that'll be in the red. Okay. So we start here. We know that it's increasing because it's going up. And it stops at this point right here. Because if we start again, well, it looks like your graph is going down. That means it's not increasing. But we start again at the 3, 0. Once again, our graph is increasing. Okay. Now notice, right, the graph is coming from the negative position, from our x values. So it's coming from negative 5, negative 6, negative 7, negative 8, etc. So remember, if it's going from the negative direction here, that means we're going to start from our negative infinity. Now we stop at our first turning point. Remember we talked about those. So here at this point, negative 1.667, 6.352, that is what we call a turning point. That just means that our graph is now going from increasing to decreasing, or vice versa. So we go from negative infinity, and then we go up to our x value of the turning point. So we go from negative infinity to negative 1.667. So those are the x values in which our graph is increasing. Now the other place which the graph is increasing is we start at 3, 0. This is another turning point here. So we go from 3, 0, and then our x values are getting bigger, right, as our graph is increasing. So because we have multiple intervals of which the graph is increasing, we have to use the union sign. So make sure you have that. So now remember, we start at our x value because we're looking for basically between what x values does our graph increase. So we start at 3, and then we go on to infinity. Now, remember, infinity signs, we always use parentheses. But you might be wondering, why are we using parentheses around our numbers? Because the dot, right, the point is filled in. Well, the reason being is that this is our turning point, okay? So here, this is where our graph stops from increasing, and then it starts to decrease. So we can't include this because it's actually, in this case, our local max, okay? So it's really, that point specifically is neither increasing nor decreasing. It's just the stopping point. And same thing at 3, 0. 3 zeros are turning points. In that case, it is the local min. So it's neither increasing nor decreasing. It's just our stopping point, really our starting point of where the graph's increasing again. So now intervals for when the graph is decreasing. That means if we're reading it left to right, when it goes down. And you can see this is happening in the middle of our graph. So once again, we want to write it using the x values. Now if you look, we stopped at negative 1.667 when we were increasing. And that's when we start again when we decrease on our interval. So we start at 1.667. And then we stop decreasing at our turning point, which is at 3. So really there is only one interval in which the graph is decreasing. And so this would be your answer here. Okay. Now what if we had a different type of graph? Maybe something like this. Okay. So once again, we're going to do domain and range. Remember, domains are x values. Well, if you notice, especially if I go down, our graph should be hitting all of the x values because as this arrow is going down, it's slanting and getting more negative as our x values are, as well as our positive. So that means the domain for this is going to be negative infinity to positive infinity. In a way, actually, all polynomials, the domain is always negative infinity to positive infinity. Now, your range in this case is going to be a little bit different than the previous problem. If you notice, both arrows are facing downwards. Well, if we know both of them are facing downwards, the y values are definitely getting more negative. So we can tell we're coming from the negative infinity direction. But here, there's no arrows going up. So that means we have a limited y value. So we're looking for the highest y value. So all of these points, as you can see, is at 0 for y's. But if you look here, we have a local max. And that y value is at 4.622. So that is actually the highest point on our y values that we go. So here for the range is from negative infinity to 4.66 or 0.622. Now, here we can, just like we've done with other functions, we can use a bracket here because our point is filled in. So that means that this y value is included in the range. Now, just like last time, we're going to do intervals of which the graph is increasing. And we want to use our x values for this. So if we read the graph left to right, we start right here. And remember, it stops at what we call the turning point. So this is one of our turning points because it is a local max. Okay. Okay, we go down, so that means it is not increasing there. Okay, then we go to a local min, so that's also a turning point, and from there we increase. So in this case, we have two intervals for which the graph is increasing. Okay, so for increasing, we start from the negative infinities. And we stop at our first turning point. Now remember, we're using the x values here. So we stop at negative 3.158. Now because this point is neither increasing nor decreasing, we cannot include that x value, okay, because it's our turning point, or really our local max. Now as I said before, there are two increasing intervals. So we start up again at 0.158. So that's our next one. So we start at 0.158. And then we go to 3. And we stop at 3 because if you notice, this is a local max, so it is a turning point. Remember, any of your local max or mins are neither increasing nor decreasing. So that's why we have to use parentheses. So now we find intervals for which the graph is decreasing, so it's going down. So we start up again at negative 3.158, and this right here, it looks like it's decreasing. Okay, so now once again we start up at 3, and that looks like it's decreasing as well. So here we have two intervals of which the graph is decreasing. So we start up at negative 3.158, and we stop at 0.158. Now make sure, because if there's multiple intervals, you need to use the union sign. Now we start back up with our decreasing at 3. And because this doesn't end, we go on to the positive infinities. Now make sure, even though the arrow's facing down, that's our y values. Okay, we're thinking about x. So the x values do go on forever into the positive. Make sure if you have any questions that you ask by emailing me or coming in before or after school. Make sure also, if you need to, pause the video so that you can always go back and rewatch it. And make sure the homework is on Google Classroom and it's problems from the textbook.